Hi everyone, welcome to this beginner-friendly tutorial on Python programming. If you're new to coding or just looking for a refresher, you're in the right place. Python is one of the most popular programming languages in the world, used in everything from AI and data science to web development and automation. And the best part, it's simple and easy to learn, making it the perfect choice for beginners. In this video, I'll guide you step by step through the basics of Python. So by the end, you'll be writing your very own Python programs. Ready? Let's dive in. On Windows, it's very easy to install Python. Just go to python.org, then in the download section, click on download. Add to path wherever you see something like this and disable the path limit. You're done and Python is installed. You also need an IDE, Integrated Development Environment, which is a software tool that combines a code editor, debugger, and other features to streamline programming. This is basically what you need to write your code and run it. Visit jetbrains.com/PyCharm to download the PyCharm IDE. Click on download. Let's scroll the page because we don't want the PyCharm Professional, we want the Community Edition. And click on download again. Installing PyCharm is very easy. Just click on Next and choose a location for it to be installed. And don't forget to add to path. This is really important. And create a shortcut if you want to. Okay, so very simply search PyCharm within the start menu and accept the terms wherever needed. I don't like data sharing, so I won't share it, and skip if it asks you to import settings from any other app. Create a new project and you'll see it can detect the Python already installed on your computer. It may take a while for it to launch everything. Make a new Python file called test.py and write print hello world. Save it and run it. This is your first Python program. Before getting started, I want you to be introduced to Mary, my assistant. Mary, please introduce yourself.
Hi, I'm Mary, your coding buddy. Let's make programming fun and easy together.
Okay, we will start with variables. Mary, what can you tell me about variables?
Variables in Python are containers for storing data values, defined with an assignment, and can hold different data types, including numbers and strings.
Thanks, Mary. Let's start coding. Okay, let's start with defining variables with different data types. First, I define a variable called name, and this variable is of kind string. Basically, it means that it stores some bunch of text. So we have a variable called name, and the value of that variable is a text, and that text is Alice. So now I want to define another variable called age, and this age is 25. The value of it is 25. So this is the name of the variable. This is the assignment character used for defining variables, and after that sign we put the value of it. If that value is kind of string, meaning that it's text, we need these quotes. It can be single quotes or double quotes. And this is just a comment. So we can use the hashtag sign to start commenting on any line, meaning that everything after that hashtag is included within the comment and will not be executed. So whenever the IDE sees this hashtag sign, this hashtag character, it treats everything after that character in the same line as a part of the comment. And comments are used just to indicate something to other programmers or just to write some kind of tip or a guide for the others who read this code. And so we want to define another variable now. Now I want to define another variable called height, and it should store a decimal value. It's a float number. It has a floating point. It's 5.6. So you see that when defining a variable of kind a number or float, an integer, there's no need to put quotes or double quotes. Okay? And finally, I want to introduce you to Boolean variables. These variables store true or false values, like this one, is underline student. This is the name of the variable, and the value of it is true. It can represent that somebody is a student. Okay? It's a Boolean variable. It stores only two things. One of these two things, false or true. And here is it storing true. So finally, using the print function, I want to display each variable's value. For displaying the value of the name, I use the print function. I open the parentheses and I put this string and then a comma and then the name of the variable. So this is one type of using the print function. And again, I use this pattern for other variables too. Note that I'm not obligated to put this string here. I can write age, but then what will be printed will not represent the truth. So this is just something that I'm using to make the output make sense. Let's see the output actually. Also, I want to write something similar for the is students variable, and now I run the code. This is the output. Name is Alice, age is 25, and height is 5.6, and is a student is true. Okay, let's see the next slide. We want to talk about updating variables. First, we define a variable age with an initial value of 25. Next, we update age by adding 5 to its current value. Finally, we print the updated value of age using the print function. Now I run the code, and you see that the incremented value of age actually is printed. So how can we use variables in expressions? Here we define a variable base to store the base of a triangle. It's 10 actually. Next, we define a variable height to represent the triangle's height. And then we calculate the area using the formula half the base times the height. Finally, we print the area with a descriptive label. Another cool thing about Python is that we can assign multiple variables in one line. Let's see how. We assign values to 3 variables, x, y, and z in a single line. You see they are just separated by a comma. X is equal to 1, y to 2, and z to 3. Then we can print the value of each variable with its label. I run the code, and the result is printed. We can swap variables values in a really cool way in Python. So first I define a variable a with the value of 5 and the variable b with value of 10. And to swap the value of these variables, I just write a comma b equals b comma a. Using this swap syntax is really cool. And this is how we can exchange the values of two variables. Finally, I can print the new values of a and b to confirm the swap. Let's run the code now. And this is it. A was 5, but it's now 10, and b was 10, but its current value is 5. Let's talk more about the strings. We start by defining a string variable called name with the value Alice. Next, we create a greeting string by concatenating hello and the name using the plus operator. Finally, we print the greeting message. We run the code, and hello Alice is printed. Pay attention that this comma is the same comma that is printed here. Moving to the next slide. I want to talk about how we can access the characters inside a string. So you have a bunch of text and you want to access characters comprising that text. The question is how you can access specific characters in a string. So we want to write a program to print the first and last characters of a word. First, we define a string variable word with the value Python. Then we access the first character using word 0 and print it. To access the last character, we use word -1 and print it. Let's run the code. You see the first character is P, it's uppercase, and the last character is N, lowercase. Let's move on. We have a cool thing in Python called string slicing. It basically means that we slice a string and we get a part of it. We define a string variable word with the value programming. To extract the first 4 characters, we use the slicing syntax word, square brackets, colon, 4. It means until the index 4. And pay attention. In computer science, we always start from 0. So when I say 4 until 4 means actually until 5 in the human language. I mean, we get the characters until the 5th one. To extract the last 5 characters, we use word, open square brackets, -5, colon, and close brackets. Finally, we print both slices. You see that the first 4 characters are prog, and the last 5 characters are min. Pay attention that P is at index 0, R is at index 1, O is at index 2, and G is at index 3. So we get the characters until we reach the 4th one, and we don't get it. We don't get the 4th one. This is really important. Now I want to talk about making a string lowercase or uppercase. I mean, the whole characters of it should be converted to lowercase or uppercase in some cases. And I want to talk about how we can deal with this thing, with this situation. First, we define a string variable text with the value Python is awesome. Then using the .upper method, we convert the string to uppercase, and using the .lower method, we convert the string to lowercase. Finally, we print both the uppercase and lowercase versions. You see, the uppercase is Python is awesome with whole characters written in uppercase, and the lowercase is the reverse of it. Let's move on to the next slide. Sometimes we want to check the content of a string. For example, I want to know if a specific word is included within a sentence. That sentence is a string variable, and that word is another string variable. Okay, so how do we do this? First, we define a string variable sentence with the value the quick brown fox. Then using the starts with method, we check if the string starts with D and print the result. Using ends with method, we check if the string ends with fox and print the result. Using the in operator, we check if quick is in the sentence and print the result. I want to talk about this code before running it. So inside this print function, I'm saying that you should first do this, and note that we can include single quotes within the double quotes. So this is the whole string here, and this single quote is actually a part of it. And then I put the comma, and something, it actually returns true or false. But that value gets converted to string within Python. This is one of the coolest things in Python, actually. Let's see the result now. Starts with D is true, ends with fox is true, and contains quick is again true. Let's move on. I want to talk about formatting strings. First, I define a string variable name and an integer variable age. Using an if string, I embed name and age inside the formatted string. And finally, I print the formatted string. Let's see the results. You see that name is placed here and age is placed here. This is called formatting strings. Let's move on. I want to talk about repeating strings now. I define a string variable text with the value high. Using the multiplication operator, I repeat the string 3 times. And finally I print it. Let's see the result. It's printed 3 times. Let's move on. How can we find the position of a substring in a string? We want to write a program to find the position of the word fox in a sentence. First, I define a string variable sentence with the value the quick brown fox jumps over the lazy dog. Using the find method, we find the position of the word fox. Finally, we print the position. Let's run the code. You see that the position of Fox is 16. It means that this f is at index 16. Moving on to the next slide.
Operators in Python are symbols or keywords used to perform operations on variables or values. They include arithmetic operators like addition and subtraction, comparison operators to compare values, and logical operators to combine conditions. Operators help manipulate data and control the flow of a program effectively.
Let's talk about arithmetic operations in Python. First, we define two variables a and b with values 10 and 3 respectively. Using the plus operator, we perform addition and print the result. Next, we use minus for subtraction and asterisk for multiplication and print their results. For division, we use a slash to get the result with decimals and print it. Using two slash signs, we perform floor division, which gives the integer quotient, and then we print it. We calculate the remainder using the percent operator and print it. Finally, we use two asterisk signs for exponentiation to compute 10 raised to the power of 3. Let's run the code now. Let's move on. I want to talk about comparison operators in Python. We define two variables a and b with values 10 and 5. Using the greater than operator, we can check if a is greater than b and print the result. Obviously, using the less than operator, we check if a is less than b and we then print the result. We use two equal signs to check if a and b are equal. The combination of exclamation and equal sign is used to show if they are not equal. Finally, we use greater than or equal sign and less than or equal sign to check if a is greater than or equal to or less than or equal to b and print the results. Let's run the code. Is a greater than b is true because a is 10 and b is 5. Is a less than or equal to b? This is false because 10 is not less than or equal to 5. Let's move on to the next slide. Now, let's talk about logical operators. We define two Boolean variables, a as true and b as false. Using the AND operator, we check if both a and b are true and print the results. Using the OR operator, we check if either a or b is true and print the result. Finally, we use the NOT operator to negate the value of a and print the result. Let's run the code now. You see a and b is false because not both of them are true. But a or b is true because just one of them is true, or at least one of them. And not a is false because a was true. You got it? So let's move on. Now we want to combine comparison and logical operators. First, we define a variable age with the value 20 and the Boolean variable has ID as true. Using the greater than or equal operator, we check if age is greater than or equal to 18. And using the AND operator, we combine the age check with the condition has ID. Finally, we print the result which determines if the person can enter the club. Let's run the code. Can enter the club true because age is 20, which is greater than or equal to 18, and has ID was true, the person has an ID. So, let's move on. Now we want to use arithmetic and comparison operators together. We define two variables, a and b, with values 10 and 5. A is 10, b is 5. Using a plus b, we calculate the sum, and using a times b, we calculate the product. We compare if the sum is greater than the product using the greater than operator. Finally, we store the result in a variable and print it. Let's run the code. The sum, which is 15, is not greater than the product, which is 50. So, the result is false. Let's move on.
Conditional statements in Python allow the program to make decisions based on certain conditions. The main keywords used are if, elif, and else, which help execute different blocks of code depending on whether a condition is true or false. These statements make programs dynamic by allowing different outcomes based on the input or situation.
I want to talk about if statements. First, we define a variable age with a value of 18. Using the if statements, we check if age is greater than or equal to 18. If the condition is true, the indented block of code runs, printing you are eligible to vote. Let's run the code. As age was 18 and it was greater than or equal to 18, you are eligible to vote. Moving on to the next code. I want to talk about if-else statements. We want to handle both the true and false cases of a condition, and this is where we use these statements. First, we define a variable age with a value of 16. Using the if statement, we check if age is greater than or equal to 18. And if the condition is true, the code inside the if block runs, printing you are eligible to vote. If the condition is false, the code inside the else block runs, printing you are not eligible to vote. Now let's run the code and see the results. You are eligible to vote. Let's move on to the next piece of code. We want to combine if, else if, and else. And else if in Python is shortened to elif. We define a variable called a score with the value of 85. Using an if statement, we first check if the score is greater than or equal to 90 and print grade A if true. If the first condition is false, we move to the elif condition, checking if the score is greater than or equal to 80 and printing grade B if true. Additional elif statements handle other ranges like grades C and F, and if none of the conditions are true, the else block runs, printing grade S. Let's run the code now. And this is it. The grade is B. Now I want to talk about nested if statements. We use them to handle more specific conditions. We will be introduced to these things in the next piece of code. So, here first we define a variable age with a value of 20 and has ID as true. Using the first if statement, we check if age is greater than or equal to 18. Inside this block, we use another if to check if the person has an ID, and if both conditions are true, we print you can enter the club. But if the person is old enough but lacks an ID, the inner else block runs, printing you need an ID to enter the club. If the age condition is false, then what happens? The outer else block runs, printing you are not old enough to enter the club. Let's run the code now. And this is it, you are old enough. Let's move on. I want to write a program to classify a person based on age and employment status. First, I define two variables. Age is 25 and is employed as true. Using the if statements, we check if age is greater than 18 and is employed is true, and print you are an employed adult. If the first condition is false, we use the elif to check if age is greater than 18 and is employed is false. And print you are an unemployed adult. If neither condition is true, the else block runs, printing you are not an adult yet. Let's run the code, and the result makes sense. Okay, let's move on. I want to tell you about if statements with input. Here, first we use the input function to prompt the user to enter their name, and then we store that name in a variable called name. As you see, this is how I get the name. I get a prompt, enter your name, and then the user should enter their name. So, after this, using the if statement, we check if name contains any value, and if true, we print a greeting message using the name. But if the user provides no input, the else block runs, printing you didn't enter a name. Let's run the code. I typed the name Alice and it says hello Alice. Let's move on.
Loops in Python are used to repeat a block of code multiple times. The for loop iterates over a sequence like a list or range, while the while loop repeats as long as a condition is true. They help automate tasks and reduce repetitive code.
I want to write a program to print numbers from 0 to 4 using a for loop. We use a for loop to iterate through the numbers generated by range 5. Range 5 actually produces numbers from 0 to 4. In each iteration, the loop variable I takes on the next number, and we print it with the label number. Okay, let's run the code now. All numbers below 5 are printed. We can do a similar thing with the while loop. In order to do that, we define a variable count with an initial value of 0. Then using a while loop, we check if count is less than 5. And inside the loop, we print the current value of count with the label count, and we increment count by 1 using count plus equal 1 to avoid an infinite loop. Okay, let's run the code now. The result is the same. Now I want to talk about something else. How can we run a program to stop a for loop when a specific condition is met? To do this, we use a for loop to iterate through numbers generated by range 10. Inside that loop, we check if the current value of I is equal to 5. If the condition is true, The break statement exits the loop immediately. For other values, we print the value of I with the label value. Let's run the code now, and here is the results. Now, how can we skip the rest of the code in the current iteration and move to the next iteration? We have a continuous statement for this in Python. We use a for loop to iterate through numbers generated by range 5. Inside the loop, we check if the current value of I is equal to 2. If the condition is true, the continuous statement skips the rest of the code for that iteration. For other values, we print the value of I with the label value. Let's run the code now, and this is it, just 2 is not printed. Now I want to talk about nested for loops. We use nested for loops to print all combinations of 2 numbers now, and in a general view, we use a for loop inside another for loop to iterate over multiple dimensions. This is the application of nested for loops. We use an outer for loop to iterate through numbers 0 to 2 using range 3. Inside the outer loop, we use a nested for loop to iterate through numbers 0 to 1 using range 2. In each iteration, we print the current values of I and j in the format I colon curly braces, I curly braces, comma, j colon open curly braces, j, and close curly braces. Let's actually run the code now to see all combinations of these numbers. We can use while true to create an infinite loop and the break statement to exit the loop when a condition is met. We define a variable count with an initial value of 0. We use while true to create an infinite loop. Inside the loop, we print the value of count with the label count. We increment count by 1 to avoid an infinite loop. When count reaches 5, the break statement exits the loop. Let's actually run the code now. This is the result.
Lists in Python are used to store multiple items in a single variable. They are ordered, changeable, and can hold different data types. Lists help organize and manage collections of data efficiently.
We can use square brackets to create a list separating elements with commas. We create a list called numbers containing the elements 1, 2, 3, 4, and 5. Using the print function, we display the entire list with the labeled numbers. Okay, run the code now, and you see the list of numbers. I create a similar list called numbers with 5 elements. Using numbers bracket 0, we access the first element of the list and print it with the label first element. Using numbers -1, we access the last element of the list and print it with the label last element. We use the append method to add an element to the end of a list. We create a list called numbers with the elements 1, 2, and 3. Using the append method, we add the number 4 to the end of the list, and finally we print the updated list. We use the remove method to delete the first occurrence of a specific value from a list. We create a list called numbers with the elements 1, 2, 3, and 4. Using the remove method, we delete the number 2 from the list. And we finally print the updated list with the label updated list. We can iterate over a list using for loop. Here we create a list called numbers with the elements 1, 2, 3, 4, and 5. Using a for loop, we iterate through each element of the list. In each iteration, we then print the current elements with the label number. We use the sort method to sort a list in place in ascending order. First, we create a list called numbers with unsorted elements 5, 3, 1, 4, and 2. Using the sort method, we arrange the elements in ascending order. Finally, we print the sorted list. Now question, how can you reverse the order of a list in Python? First, we create a list called numbers with the elements 1, 2, 3, 4, and 5. Then, using the reverse method, we change the order of the elements to be in reverse. Finally, we print the reversed list. We use the len function to get the number of elements in a list. Here we create a list called numbers with the elements 1, 2, 3, 4, and 5 again. Using the len function, we calculate the total number of elements in the list, and finally we print the result.
Tuples in Python are used to store multiple items in a single variable. They are immutable, meaning their values cannot be changed after creation. Tuples are defined using parentheses and are useful for grouping related data.
Now we want to define a tuple, which is an immutable collection of values. First, we define a tuple called coordinates with the values 10, 20, and 30. Using the print function, we display the entire tuple with the label coordinates. Accessing the elements in a tuple is really easy and is the same as accessing elements in a list. So we define our tuple, the coordinates as before, and we get the first element with index 0 and the last one with index -1, and we just use the print function to display them.
A set in Python is a collection of unique and unordered elements. It is defined using curly brackets or the set function. Sets are useful for removing duplicates and performing operations like union and intersection.
We use curly braces to define a set, which automatically removes duplicate values. We define a set called unique numbers with the values 1, 2, 3, 3, and 2. Since sets automatically remove duplicates, only unique values remain. Using the print function, we display the set, which only consists of 1, 2, and 3. Adding and removing elements in a set is really easy. We define a set called unique numbers with the values 1, 2, and 3. Using the add method, we add the number 4 to the set. Pay attention that it's not being added to the beginning or the end of the set, because sets do not have an order. And using the remove method, we delete the number 2 from the set, and finally we print the updated set with the label update set.
A dictionary in Python is a collection of key-value pairs. Each key is unique and is used to access its corresponding value. Dictionaries are useful for storing and retrieving data efficiently.
We use curly braces to define a dictionary with key-value pairs, separated by a colon. First, we define a dictionary called students with keys name, age, and grade. Each key is paired with a corresponding value, Alice, 20, and A, respectively. Finally, using the print function, we display the dictionary. We use the key inside square brackets to access a value in a dictionary. We define a dictionary called students with keys name, age, and grade as before. Using student's name, we access the value associated with the key name and print it with the label name. Using student age, we access the value associated with the key age and print it with the label age. Updating values in a dictionary is very easy. We define a dictionary called student with the same keys and with the same values. Using student, grade equals A+, we update the value of the key grade to A+. Finally, we print the updated dictionary with the label updated student info. Now, how can we check if a key exists in a dictionary? We define a dictionary as before, and using the in keyword, we check if the key age exists in the dictionary. If the condition is true, we print age is available. And if it's false, we print age is not available.
Functions in Python are reusable blocks of code that perform specific tasks. They are defined using the def keyword followed by a name and parentheses. Functions make code organized, reduce repetition, and can take inputs and return outputs.
We use the def keyword to define a function and call it by its name followed by parentheses. We define a function called greet using the def keyword. The function contains a single statement that prints hello world. To execute the function, we call it using its name followed by parentheses. Greet. How can we pass information to a function? You want to write a program to define a function that takes a name as input and prints a greeting. You can add parameters inside the parentheses when defining a function to pass data into it. We define a function called greet that takes one parameter, name. Inside the function, we use an f-string to print a personalized greeting. We call the function twice, passing Alice and Bob as arguments, resulting in two different greetings. Now I want to define a function to add two numbers and return the result. I define the function called addNumbers that takes two parameters, a and b. The function uses return statements to send back the sum of a and b. And we call the function with the arguments 5 and 3 and store the result in a variable called result. Finally, we print the result with the label result. Functions can have default parameters. We define a function called greet that takes one parameter, name, with the default value of guest. If no argument is provided when calling the function, the default value is used. We call the function without an argument to print hello guest and with the argument Alice to print hello Alice. Functions can return multiple values. Here we define a function called calculate area and perimeter. The function takes two parameters, length and width. The function calculates the area and perimeter of a rectangle. Using the return statement, we send both values back as a tuple. We call the function with arguments 5 and 3 and unpack the return values into a and p. Finally, we print the area and perimeter with their respective labels. Functions can be used inside loops. Here we define a function called a square that takes one parameter, num. The function returns the square of the input number. Using a for loop, we iterate through the numbers from 1 to 5. In each iteration, we call the square function and print the result with the descriptive label. We can also have recursive functions in Python. A recursive function calls itself to solve a smaller instance of the problem. Here we define a function called factorial that calculates the factorial of a number. If the input is 0 or 1, the function returns 1, base case. Otherwise, the function returns n multiplied by the factorial of n minus 1. This is the recursive case. We call the function with the argument 5 and print the result with the label factorial of 5. This is it. You learned the basics of the Python programming language. See you later.